Hello students. Now in this module we are going to learn about the cyclization of open chain structure. Let's start with this first. Now we studied an open chain structure for glucose, but the problem with the structure was that this structure was not able to explain a reaction with 2,4-DNP, that is 2,4 dinitrophenyl hydrazine. Also, it could not explain a reaction with NaHSO4, that was a trademark aldehyde reaction. Also, it gave a negative test with Schiff's reagent. So this all points prove that there is no presence of an aldehydic group into a glucose molecule. But we have studied that it consists of an aldehyde molecule. So, a new theory was proposed, and later on it was found out that glucose actually exists into two different forms, that is the alpha form and the beta form. And according to this, what we need to know is, it is generally observed when alcohols add to the carbonyl group in the presence of an acid, they give either a hemiacetyl or a hemiketyl. And these aldehydes or ketones and hydroxy, when they are the part of the same molecule, they result in formation of a more stable hemiacetyl or hemiketyl structures, mind it, stable than the open chain structures. So now, let's understand this same point. We had an aldehydic group to which suppose we add an alcoholic group. What happens because of this? Then the partially negative oxygen of alcohol along with the R attacks to the carbon atom, and because of this we get a compound called as hemiacetyl. And again, if the same reaction was repeated using a ketone molecule, let's see what happens. We have a ketone R C double bond O R dash. To this we are adding one alcohol molecule. Again, the partial negative of oxygen would go and attack to the carbon atom, giving me a hemiketyl which is formed. So this was all the reaction which we are going to study in this module. Let's move further. Now, the problem with us is we require alcoholic as well as aldehydic group. Let's take an example of our molecule D-glucose. We have an aldehydic group, we have an alcoholic group. And let's now suppose that the second carbon OH attacks onto the first C double bond O. What would happen? We would get an hemiacetyl which would be a 3-membered ring. And suppose now, if the next OH, that is OH of the third carbon, goes and attacks, then we are bound to get a compound which would be nothing but a 4-membered ring, something like this. Further, if the fourth carbon OH goes and attacks onto the same carbonyl group, what we would get? We would get a compound with 5 members, and the chain would be something like this. Similarly, if the second last carbon's OH goes and attack to the carbonyl carbon, then we are going to get a compound in which that member would be a 6-membered ring, something like this. And finally, if 6th carbon OH attacks onto the carbonyl group, we would get a 7-membered ring, and the ring would be something like this. If the same was followed for a molecule of fructose, let's see. Again, first carbon OH attacking onto the carbonyl carbon, giving me a compound which is a 3-membered ring. If the same compound, or if fructose, again, the third carbon atom goes and attack to the carbonyl carbon, we are again bound to get a compound which is a 3-membered ring. And again, fourth carbon OH goes and attacks to the carbonyl group, we are getting a compound which is nothing but a 4-membered ring. So that is something like this. And if fifth carbon's OH goes and attacks, then we are getting a compound that is a 5-membered ring, something like this. And lastly, we are bound to get a compound containing 6-membered ring if the 6th carbon's OH goes and attacks onto the carbonyl carbon. Here, we would get a 6-membered ring, something like this. Now, students, we need to understand a very, very important point, that whatever we have studied up till now, that is all these structures which we have done, in these structures, the 5 and 6-membered rings are the most stable rings. So that means the first, second and the last are the wrong options, and therefore we would go with the 5-membered ring, which is a ring similar to furan, whereas a 6-membered ring which is similar to pyran. This was all about this module, students. Meet you in the next module. Till then, thank you.